Hi, my name is Sean Martin. I am the owner of Donek Snowboards, and I'm going to show you how we assemble one of our metal boards today, as well as a little bit of things about the features and why we do some of the stuff we do. Now, this assembly process is only a very small part of how the board is built, but it's probably one of the most interesting simply because all of the components that we've spent a great deal of time making are finally coming together into one piece. So, I'll start and I'll show you. This is a piece of Titanol, the aluminum that we make the boards out of. And what you probably don't know is that this material, while extremely strong, is very, very brittle. I can take a razor knife and score a line across it and simply break it. It's that brittle. It's very difficult to bend. It retains its shape very well, but it is very, very brittle. And that results in a lot of potential areas for damage to the board. What we do is we move all the metal away from the edge of the board where it could get an impact or a little nick that could propagate into a very large crack or failure. The other thing we do, which is rather unique, is we pre-drill the insert holes in the aluminum so that the binding inserts can actually rise in the core when you tighten down your binding screws and actually go through the hole. As you can see here, it can actually fit through the hole. The hole is much larger than the barrel of that insert. Most of us alpine riders are familiar with something called binding suck, which is basically what's happening is you tighten down your binding screws and the bottom of the insert compresses the core a little bit and generates a little dimple or divot in the bottom of the board because we're pulling so hard on that insert. Well, when you use aluminum that's this brittle in the board, if the binding insert can't rise through the metal, it generates a small mushroom in the metal, which generates stress concentrations and potential areas of failure. And you'll see a lot of other metal boards breaking at the bindings, and this is the primary reason. It's because the insert is not allowed to freely float through the metal. It's pushing up on the metal and generating stress concentrations. The first thing I'm going to do is position my top metal laminate over my core so that my inserts are capable of going through those holes. And of course I'm going to double check that it's sized right and everything is positioned properly. Then I'm going to drill and locate some little pins that we use to hold that top metal laminate in place when it goes in the press. I've got my metal where I want it, so I'm going to drill a little very small hole in that top laminate and temporarily stick my pin in there, come down the other end, and drill another little hole. Okay, so that's done. Okay, so now what I'm going to do is just clean up my little pins and cut them to length. Okay, so my core is ready to go. And next I'm going to mix up some epoxy resin. Okay, so I've got one of my cups of resin all mixed up and the other one weighed out, ready to be mixed. So I'm going to start by assembling or saturating the fiberglass that's going to become the tip and tail sections of our board here. I'll just let them sit and let the epoxy soak into them a little bit. So next I'm going to come over here and put some epoxy down and make sure I get the epoxy all around those tabs on the edges in order to ensure that they have a really strong bond. Now, the next thing that goes down is a layer of rubber foil. Now, I'm going to press out and chase out all that excess epoxy that's under there, as well as any air bubbles. The next thing I'm going to do is fill in part of my tail extension or tail bar, depending on what you want to call it, and put in a couple layers of fiberglass that go in there. Squeeze it on down. Continue spreading out my resin in a nice even layer over my base material. And I'm going to lay down my first sheet of aluminum. This piece is pre-cut as well. It's pre-cut to fit just inside the edges. And the edges actually form a little barrier to keep it from moving around. So we don't need those pins down here. So I'll just make sure I got it positioned perfectly. And then move on to my next layer, which is a layer of carbon fiber. This is unidirectional carbon. It runs the entire length of the board. Provides a little bit of extra snap and pop to the board. And I'm going to grab a piece of my tail extension that I pre-assembled earlier, or actually pre-wet earlier. And I'm going to put it in position. And then I'm going to pick up my cord and position it where it belongs. And grab my tip extension. Alright, it's time to mix up more resin. This is a free carve board I'm making, so it gets a single layer of rubber. And that's my next layer down. If I was making a race board, I'd put a layer of rubber underneath the core as well as on top of it. Alright, here's my rubber. Okay, so now down goes my carbon fiber. It's a layer identical to the one I put on the bottom. And down goes our top layer of metal. And I'm going to locate those little pins that I have on the core through the holes. And my metal just drops right on there. And what I'll do next is grab my pliers, pull those ones out, and put in the ones I cut. Okay, take off my gloves and I'll position my top sheet. And this board is ready to go in the press. Now the press is a device that squeezes all of the laminates together, and it'll apply about 20 or 30 tons of pressure on the board. It depends on the length, of course. And what that does is it laminates all the layers together, forces all the extra glue out of the laminates. All the air bubbles get chased out along with that extra resin. And it has the bend shape of the board, basically the camber in the middle and the kicks or the bends in the tip and the tail, built into the mold that it goes into. So That's it. I'm going to put it in the press.